Okay, today we're going to be talking about fractions and decimals and converting back and forth between them. We're also going to talk about fractions written with variables in them and how to write those in different ways. So I first want to talk about different ways to write fractions with variables. So for example, a lot of us have seen something written like this, 1/2 x. That's actually the same thing as saying 1/2 times the variable x, which you probably already knew. It's also the same thing as saying 1x over 2. So when you have 1/2 x, it's really the same as saying 1x on top, that's your numerator, divided by 2, which is your denominator. Or you could even just write it as x over 2, because you don't actually need the 1 in front of the x here. And the reason that that's true is because when you have the original problem, this 1/2 x, 1 over 2 multiplied by x, x is the same as saying x over 1. Remember, when you don't have a denominator, it's always over 1. And then, so if we're just going to multiply these two fractions together, on top we have 1 times x, which is 1x, and on bottom we have 2 times 1, which is 2. And so that's why you end up with 1x over 2, or just x over 2. So, for an example, I would like you to go ahead and try to rewrite 5/8 x. That's our first example here. Take a second and try to rewrite that on in your notes. So you should have realized that the x is also a numerator, which is the same as x over 1. So we would get 5x on top and 8 on the bottom. So 5x over 8 is another way to write 5/8 x. Our next example problem is to reduce 3x squared divided by 9. So in order to do that, we could actually simplify the fractional part here. 3 over 9, if we simplify that, is the same as 1 over 3. And then we still have x squared on top. So it could be 1x squared over 3, or we could write this as 1/3 x squared. Same thing. These two answers here are the same. Okay, so I'm going to erase this real quick. Pause the video if you need it. And I'm going to move up, maybe. And I'm going to move up to this simplifying problem. So it says simplify 6/18, and this is a times sign here. I just didn't show it very well, times x over 4. So we're simplifying this problem. There's several ways you could go about doing this. You could, first of all, you could simplify the 6/18 first, but we're going to have to reduce it in the end anyway, so it's probably better if we just multiply across here. So 6 times x would be the numerator, 6x, and 18 times 4 would be the denominator, which ends up giving us 72. And so now, like I said before, we can reduce this. 6 over 72 is the same as 1/12, so we have 1x over 12, which is the same as saying 1/12 x. And so either of these answers would be correct. You could write it either way. So now let's talk about how to take that 6 over 72 and figure out that it's 1/12. The first thing you would do is go into your calculator and divide 6 divided by 72. And when you do that, you get this long fraction like this, right? And so then we can take our calculator and push the math key, which is in the top left sort of your calculator, and you're going to push math enter, and that will actually change it back into a reduced fraction for you. So that is something we need to write on our calculator tips, which is at the front of your notebook. So if you'll turn to your front of your notebook, and at the very front where we have the page titled Calculator Tips, we're going to write math enter, and then we're going to write what it does for us. So math enter changes a decimal into a reduced fraction. So go ahead and write that on the very front page of your notebook, titled Calculator Tips. You can also write it on these notes if you want, but you don't have to, then it would be written twice. And then go ahead and turn back to your notes on fractions and decimals. And we're now going to talk about converting between fractions and decimals. So let's write a few problems and see if we can figure them out. So let's write 1/3, 2/3, and 1/2. So those will be our example problems. So 1/3, if we want to change that into a decimal, we would do 1 divided by 3. And when we do that in our calculator, we get 0.333, like that. So let's say we round that off. Remember, the rounding rules tells us to, if we want to round it, let's say to the hundredths place, we're going to stop it here. And when we look next door, this is not more than 5, so we would just leave it as 0.33. So, oops. So let's erase, if I can. Bear with me while I erase this. Well, I'll just scribble it out for us. So 0.33. 2/3, we can do the same thing. When we do that, we get 0.666. Let's say we want to round that off to the hundredths place as well. So we're going to stop here. We look next door, and the rule says if this is 5 or more, then we give this guy a score. So that's going to round it to 0.67. And then the last fraction we have is 1/2. And when you divide that, 1 divided by 2 gives you 0.5. We don't have to round that off. It's just already like that in the calculator. So then we want to talk about if these things are equal. So 1/2 is exactly equal to 0.5. That's a true statement. Those are exactly the same, and they're not any different. And the reason I know that is because I can tell that this 5 here is in the tenths place. So 0.5 is really talking about 5/10. And if I reduce 5/10, what do I get? I get 1/2 back. So they're exactly the same. 2/3 and 0.67 are close, but they're not exactly equal. And in reality, 0.67 is actually bigger than 2/3 because we rounded up over here when we did our rounding. We rounded this 6 up to a 7, and that made this a bigger number than 2/3. Another way you could tell is you could say 0.67, this is 67 hundredths because that 7 is in the hundredths place. And if you did 67 over 100 and compared it to 2 divided by 3, you would see that this number is the bigger number. And then 1/3 and 0.33, we actually rounded the 0.33 down. We didn't lower the number, but we did not, we cut off the 3's here. We stopped it. And so this is actually 1/3 is a bigger number than 0.33. So when you're converting between decimals and fractions, it's not always going to be exactly equivalent. Sometimes when you're rounding, if you have to round off your decimal, it's close, but it's actually not the exact same as the fraction. The fraction is always going to be the more accurate answer than the decimal you have to round. All right, that is all the notes for today. I think we have a game and a worksheet that we're going to play.